So we're looking at the test review right now for Chapter 7. We're just going to look at the first half of the review, which is 7.1.12 to 7.1.16. Tomorrow we'll do the other 4 problems. So in 1.12 here it says to decide if each triangle below is congruent to ABC at the right. I went ahead and copied ABC right here so we kind of can see them more closely. Justify each answer with a sketch if you need to. We just need to see if these are congruent. And then if they are congruent, then what do we do to get from here to here? That's called the rigid transformation. So what rigid transformation maps that onto these? So the first thing I should do is gather all the information from the picture. So if I look first at triangle ABC, what information do I have in that picture that maybe is not in there, but I can add to it pretty easily? Tyler? Angle B. So if I want to find angle B, what would I do?
You
Chris?
add the two measurements that you have and subtract that from 180.
So add these two angles together, subtract it from 180, so that would be 105. So B would be 75. So let's put that in there. Okay, so that's 75. So knowing that now, it's helpful if I do the same for the other ones, just so we have them. So on A, what would be angle X?
40.
So 165 plus 75 is 140, so that'd be 40 degrees. And on B, what would angle N be? 45, so 75 plus 50 is 125. 125 subtracted from 180 is 55. And then on C, what's the measurement of angle R?
65.
So we have 1/8. So 75 and 40 is 115. 115. So that would be 65. So now we can look at these triangles. And first, we need to see, do the angles match up? So which of those do the angles match up on?
A and C.
A and C. So B is out. B doesn't have the same angles. B is out. Not congruent to that one, as different angles. Okay, now we look at the side that has 8, and we have to make sure that both of these have sides that have 8, and they do. But only one of them actually lines up. Which one is that?
C.
C. So do we see here how the 8's here and here? This 8 is between the 40 and the 75. And this 8 is between the 75 and 65. It'd have to be between the 40 and 75 to be congruent. So A is out. So C is between the 75 and 40. And it looks like I can take this and rotate it, and it would be congruent, right? So it would just be a rotation. You could say a counterclockwise rotation to be congruent. That would be your transformation. Questions there? Okay, on 7.1.13, it says for each part below, decide whether the triangles are congruent or not. If they are, justify using the congruence condition. So all we need to do is say if they're congruent and why, using our congruency statements. So let's zoom in on this a little bit. On A, would A be congruent? Yeah, but don't you need 3 parts? It only has 2, right?
But they share the same side.
They share the same side. So this side right here is shared, which means what would be our congruency? Side, side, side. There are no angles here. So side, side, side. Okay, what about on B? So I can see that the angles would line up here if I flipped it over, right? The 5 and the 8 would line up, so would that work?
No.
No, why not?
It's a bad word.
It's a bad word because it would be angle, side, side. Oh, no cussing in math. So Can't be determined. We showed before that if you have an angle side-side, it's possible to create a couple different triangles. So that's why it's not possible. What about on C here? They have an angle. If I rotate this around, does it match up? Yeah, if I rotate this around, it matches up. But would they be congruent? It doesn't look congruent. I see a side, and an angle side, side again there. And this one has angle and 3 sides, but still I have an angle side, side, which that means it doesn't work.
Wow.
Can't be determined. Okay? Questions on 113? Okay, on 114, 7 and 114, we're going back to equations of lines. So, every equation of a line that we find, no matter what formula we're using, what does it need? It's the first thing you're always finding usually. Your slope. So let's find the slope first. So to find the slope, what do we do with these 2 points?
You do.
Carrie.
You find the difference in x and the difference in y.
Okay, and when you find the differences, what do?
You put rise over run.
So you put the y's on top. So I just look at the y's and I go, I'm going to find the difference. So 4 minus negative 2. And since I went this direction, I have to go this direction with the x's. So 4 minus negative 2 over negative 5 minus 3. If I simplify this, I get 6 over negative 8, which is negative 3/4. Okay, so there's your slope. Now, it didn't say to put it into, y equals mx plus b form or slope-intercept form. And I don't have a y-intercept, so I would just put it right into point-slope form. And since we have 2 points here, there are 2 point-slope forms that we can have. So what I would do, I'm going to write both of them at the same time. Put them in graph-ready point-slope form, which would be y equals your slope. But instead of putting, like x plus b, we use parentheses. And then we're going to have x inside the parentheses. And what goes here?
Like x1 or x2.
Yeah, so the opposite of your x. So if that's negative 5, I'd put a plus 5 in there. So plus 5. And then what goes at the end? Right here. My y value, and I don't change that sign at all. So it would be plus 5 plus 4. So the opposite of the x, and then the actual y. So this would be minus 3, because the opposite of this 3 up here, minus 2. So either one of those works. I just leave it like that. Okay, it doesn't say to put it in, slope-intercept form, so we can leave like that. Okay, this is 115. We want to determine if the triangles are similar. How do we check for similar? Or they are similar, and how do we want to solve for x? So how do we set up an equation to solve for x? Bailey?
So you find what makes 10 go to 4, so you divide 10 by 4.
So we line up. Yeah, we're going to line up. We got to figure out which of these corresponds with which. And since this 10 right here is between the 2 and the 3 dash, the 2 and the 3 tick mark, this 4 is also between the 2 and the 3. So the 10 and the 4 correspond. So we're going to do a proportion and put 10 divided by 4. So 10 divided by 4. And what is that going to equal?
2.5.
So you want to simplify that way? Okay. So that would be 2.5. And then what are you going to do?
And then I did 2.5 plus 5, so you plug the x in, and then you get 7.5.
So 2.5 plus 5. So you plug the 2.5 into the x?
I got the answer right.
Yeah, I'm not sure if that'll work on this one, though, because you have to multiply. That's your multiplier. If we want to do a proportion here, and we have 10 over 4, we can do
Equals
x plus 5 over 5.
The 5's cancel.
Oh, the 5's will not cancel here. So I'm not going to do that. I'm not going to do 2.5 there.
Oh, it's not one.
Just do 4 times x plus 5 and 10 times.
Right, so we do cross multiplication. So we have 4 times x plus 5
Which is 4x plus 10.
equals 10 times 5 is 50. So we get 4x plus 20 equals 50 minus a 20. So 4x equals 30. Divide by 4 and you still get 7.5. All right. Questions there on similarity? Okay, this is 7.1.16. So this is our long part because it's a flow charts on it. So it says determine whether the two triangles are congruent. If they are, put a flow chart, and if not, then just say why. So justify your conclusion. So let's look at A first. Let's get rid of this. So A, would these two triangles be congruent and why? You said yes. Why? Because you have two sides on each triangle, and what else?
The angle point.
The angle in between.
So it's side angle side.
So it'd be side angle side. So let's go ahead and do a flow chart for that. Now, almost all of our flow charts, actually everyone's going to start with the three, you can do the three pieces that flow into the one. And the one is always the triangle congruent. So I'm going to go ahead and start at the bottom here. Triangle BIG is congruent to which triangle? DOG. It does matter, yeah. You can start wherever you want. If you go BIG, just make sure you go DOG. If you go IGB, it'd be OGB. So just or OGD, make sure you line those up. Okay, so I can actually go ahead and put that as my last reason and put side angle side. Okay, so that's our last reason. Now I'm going to have three things that flow into each one of those. So in each one of those would be a side, an angle, and a side. So what's the first two sides that I see that are congruent in the picture, Skylar?
IG is equal to GO.
Okay, so let's do that. Let's go IG is congruent to GO. It's in the picture, so that is a given. Okay, I'll skip over to my other side now. What is the other side that's congruent? Yeah, so BG is congruent to DG. That is also in the picture, so that's given. And then the last part there is your angle. So what angle do you have? What angles are congruent? BGI is congruent to DGO. Kind of overflow in there. It's all right. And what's the reasoning for that? How do I know that? How did I know those are equal? Carrie? Vertical angles. So put vertical angles, and you can shortcut that.
So the rule of vertical angles is just if they're across from each other?
Yep. If it makes an X like that, and they're across from each other, those are vertical angles. And you're pretty much done. Put a little tombstone at the end to say you're done. And you're good. So looking at B now. Let's get rid of C and D for right now. So I'm looking just at B. Okay, and what reasoning did you have there? Said angle, side, angle? What side does it have? I see two angles. Yeah, share a side right there in the middle. So I agree with the angle, side, angle. So same idea, same process here is I would do the triangles first, and I'll switch it up a little bit. I'll do triangle gib is congruent to triangle gab. We already know it's an angle, side, angle. We can tell that from the picture. Now we just need to finish the proof here with your angle, your side, and your angle. So start with the first angle. Angle IBG is congruent to angle ABG. That is a given. Okay, and I'll put my last angle over here too. Actually, on my side would be what? BG is congruent to VG. I put same side there. Maddie? Okay. Yeah, there are always, good question. Here, on your proofs, that's on your quiz, people didn't do it. You have to have, on a flowchart proofs, you're going to have a bubble, that's your statement, and underneath the bubble is your reason. It's got to have both of those. If it doesn't, it's not complete. Okay? So, we have those, and then we have our last angle. So, angle IGB is congruent to angle AGB. And that was also given because it was in the picture. If it's in the picture, without us doing anything, just looking at it, oh, there it is, then it's given. If it's like I saw because they're vertical angles, then it's vertical angles. Done. Questions there? We're flying right along here. Good job so far. Okay, we're looking at C now. Let's go ahead and get rid of A and B. Looking at C, I see the triangles, Audrey, that we have. So I see a side, and I see an angle. Is there any other information I have in there?
You have a side. Same side.
The side they share. So now what congruency do I have?
Side angle, side.
I only heard one person say the correct one here. I only see one angle. It can't be determined. So, since you have two sides and an angle, and the angle is not in the middle, if the angle we had given were up here, we'd be good. But it's not. So therefore, it can't be determined, and we're done with that one. So that's your reasoning, because it's an angle side, but no flowchart proof needed. All right, last one here is going to be D. So let's look at that. So on D, the given information here, what do we have in the picture because of the givens? What do these two arrows mean? Parallel. So parallel lines will always give us equal angles. And in fact, in this situation, they give us two pairs of equal angles.
SOM.
Yeah, because these are parallel, it tells me that we have these are equal, and also these are equal. And are these equal too? Yeah, because of vertical angles. So we actually have three. So it depends on which one you're looking at here.
Couldn't it be side also?
Well, I only see one pair of sides, which is this one right here. I don't see any other sides.
They're the same length and they're parallel, and that would,
I think it's
like, any way you move it, it's gonna be congruent.
Yeah, it's going to be congruent for sure. So what I would do is say that these are equal because of parallel lines.
I think it's angle setting.
We could have, it depends what angles you want to use. Realistically, here's what we got. We have those are equal because of parallel lines. We also have these are equal because of parallel lines. We also have this is equal from vertical angles. So realistically, we have 3 angles and a side, which means they're going to be congruent. But the question is, which one do we want to use? We can use either one. We can either use angle, side, angle, or angle, angle, side. It doesn't really matter.
Angle side, angle side.
We haven't used an angle, angle, side yet, so I want to use that one. So let's go this way. So we have an angle, angle, side. I'm going to start with my triangle. Triangle sit is congruent to triangle SMO. Be careful, because the I and the M are equal. See right here, the I and the M are equal. So they got to be in the same order here. Circle that. And you said our study I wanted to use angle, angle, side, because we haven't used it yet today. Okay, so I'm going to start on the right side here. My side that's equal is IT is congruent to OM. That was given.
They share the same side.
Okay. There aren't any sides that are
Oh,
shared.
No, sorry, we're not using it.
I'll use angle S in the middle there. So angle IST is congruent to angle MSO. Those are vertical angles. My penmanship's going away. So it's vertical angles. And the last one we have, we could just say angle O now. Notice why could I say angle O and T here and not angle S in the middle?
Because angle S is touching this side.
Yeah, because angle S could be a couple different angles here, where angle O is just that one. So I would say angle O is congruent to angle T. The reason we knew that was because of the parallel lines. They were alternate interior angles. So you could say parallel lines and then alternate interior angles. On the test, I would accept either one of those. You don't have to have both. I would accept either one. I know what you mean when you say parallel lines, as long as you knew that that gave you those angles. Now the thing is, we only knew that because of the given in the picture that they're parallel. So we have to have one more bubble here. We knew that IT was parallel to OM. And that's what gave us that. And that was given in the picture. So that one had one extra box, one extra bubble. Tombstone and done. Questions there?